Hello, this is the Unit 3 Climate Change Human Dimensions, Week 7, Climate Change Impacts Current and Future, mini lecture for Sci 333, Psychology of Climate Change and Disaster. So this week we're continuing our process of learning about climate change impacts. And again, I want you to direct you to consider the human dimensions of these impacts. First, we have Burns's chapter, Pacific Island Developing Country Water Resources and Climate Change, from Peter Glick's book, The World's Water. I chose this chapter because in a lot of ways it cuts to the heart of the disparity and impacts that we see across the world. Part of this does have to do with access to resources. Developing nations have less infrastructure than developed nations to deal with climate change, but a lot of it too is just the damned luck of the draw. The chapter starts out even with a quote. As one commentator has observed, one ironic and tragic aspect of this environmental crisis of greenhouse emissions is the fact that those parts of the world least responsible for creating global warming, the global warming problem, will be the first to suffer its horrifying consequences. In Tuvalu, in Kiribati, in the Marshall Islands, Seychelles, Maldives, we're talking about sea level rise to the point of inundation and making the islands entirely uninhabitable in a generation. The people who live there now may not be able to grow old in their home because the islands are so small, so low-lying, that saltwater inundation will kill the islands, will kill all of the plants and the ability to sustain life. In many islands, including in higher volcanic islands, the change in weather system with climate change also means increases in droughts, changes long periods of no rain, the land dries out, plants die, and then when the rains come, we're not seeing that slow, steady rainfall that is life-giving, but instead we're seeing extreme storms that destroy crops and cause mudslides. That don't replenish fresh water, but just flood right out into the ocean, and so they're not actually beneficial even though it's heavy periods of water. The people in these non-industrial countries have contributed so very little greenhouse gases in the atmosphere. They have done so little to cause climate change, and yet, luck of the draw, they're the first impacted and the most impacted in the world. And let's be clear, my country, my people, my heritage, my developed industrial lifestyle, this is what caused and is causing climate change. But neither I nor anyone else ever set out with this plan to cause climate change with the goal of wiping out Tuvalu. And yet we are responsible. And yet, we, the collective we in the industrialized world, have not fully taken on the mantle of this responsibility in order to protect the homelands of these countries that are already experiencing devastating impacts. Burns also closes the chapter talking about some of the resources that are being put toward protecting freshwater resources in these countries and how, even though actions are being taken, it's still, to this point, not enough. Now, in case you get bogged down in the science of the chapters in the IPCC report, Burns's chapter on the Pacific Island developing countries really does get to the heart of what is at stake now with climate change. Now, I did assign you 3 chapters in the IPCC 5th report, Working Group 1, the introduction, Chapter 11, Near-Term Climate Change Projections and Predictability, and Chapter 12, Long-Term Climate Change Projections, Commitments, and Irreversibility. As you're reading these, there are a few things that I do want to point out. First, do your best not to get bogged down by the science. These chapters, this report, it is written for people and it's meant to be in a readable language, but it's about science and it's written by scientists who have an extremely high level of expertise in the fields they're writing about. You don't have to memorize every detail, but do keep pushing through reading these chapters and glean what you can. There's a lot of great information and a lot of it is very readable. Some of it isn't, but a lot of it is, and a lot of it will fit into what you already know from having read Climate Change last week. Second, I want to point out some of the language. In each chapter toward the beginning, one of the first pages, you'll see some footnotes that say, the first one, in this report, the following terms have been used to indicate the assessed likelihood of an outcome or a result. Virtually certain, 99% to 100% probability. Very likely, 90 to 100%. Likely, 66 to 100%. As likely as not, 33% to 66%. Unlikely, 0 to 33%, and so on. And then the second footnote will say, in this report, the following summary terms are to be used to describe the available evidence: limited, medium, or robust, how much science we have back so far, and also a level of confidence that's expressed using 5 qualifiers: very low confidence, medium, high, and very high. And so these terms and these ranges are used very consistently throughout the IPCC chapters and reports, and they are meant to clarify what we know and how sure we are about it. Scientists like to speak in statistics, and that doesn't translate very well to other human people. And so this is the translation, these percentages, but saying it instead in terms of very likely, unlikely, very high confidence, low confidence, etc., etc. But even this, which is actually very clear, it's written out in every single chapter, it has led to some difficulty in understanding among lay people, what does this mean and what do we actually know in the science. So, for example, 90% to 100% is very likely. If a weather report says that there is a 90 to 100% chance of rain tomorrow, we are not going to say it is very likely to rain tomorrow. We're going to say it's going to rain tomorrow. But the nature of science and the language of science is that it is steeped in statistical probabilities and statistical confidence. A report synthesizing the work of hundreds and hundreds of scientists is simply not ever going to say this is going to happen. In reality land, where people live, when we use the term uncertainty, we use it to mean we don't know. But when climate scientists use the term uncertainty, they're talking about all of the unknowns and all of the unknowable factors that will influence this thing that they know will happen. Coastal areas are going to flood. Low-lying island nations are going to become uninhabitable. This is certain at this point. What is uncertain is when exactly that is going to happen. That could be later. It could happen later if the human race gets their act together and affects positive change. And it could be a lot sooner if there's terrible storm season. And this brings me to our next point, the difference between weather and climate, and the difference between climate change and climate variability. Weather is what is happening right now outside. And the climate is the longer trend of the region that we live in. Based on the long-term trends within Maine, and the standard is to use a 30-year period to determine what is a trend, what is climate, etc. But based on these long-term weather events and patterns that we have seen past 30 years in Maine, etc., we can say that our climate is to have cold winters and warm summers. But I can't tell you what the weather is going to be like on June 25th of next year. Those short-term trends, hourly, daily, that's weather. The general state of our region, that's climate. Now with climate change, we're talking about the breakdown of those stable climate trends and averages. Climate being the average of a long period of time, therefore the climate change is going to take a long period of time in order to see the entire breakdown of that, or the entire shift of those trends. You look at any given day, any given year, it could be unseasonably warm or cool or wet or dry, but you average all of these days together, all of these years together, and that's what makes climate, and changes to those averages is what makes climate change. But here's another wrinkle to this issue. In addition to weather variability, any given day, the way it may be outside, it could be way outside of our climate norms. We also have climate variability, some years, some decades, in which the trends are up or the trends are down. The El Nino Southern Oscillation, or ENSO, ENSO, is an example of climate variability, and it's a big one. We're in an El Nino now. The last one we had that was as big as the one that we have right now was the 97-98 El Nino. Go ask somebody who was in Maine at the time. Or if you lived in Maine, take a trip down memory lane to the winter and the ice storms that happened with that El Nino. We can expect high precipitation in the East Coast because of the El Nino winters. We know that this is what has happened previously, and we can expect that it's going to happen again this year. Will we have ice storms or blizzards? Well, there's a lot of other weather and climate variability factors that go into that. If we get some polar vortexes come by while we have a lot of moisture in the air, yeah, we really could have bad ice storms, bad blizzards. But any given day, any given storm, it's going to be influenced by a lot of these short-term and slightly longer-term and very long-term factors. We're probably going to get snow because that's the climate in Maine, but if we're going to get any particular storm, that's going to have to do with the shorter term factors as well. With climate change, because it is such a long-term process, but also because there is short-term weather and climate variability, sometimes it's going to be way worse than projected. Some years, it's even going to be better. The trends are going to go up and down, and sometimes it's going to even reverse the trend. Sometimes it's going to exacerbate it and make it way worse. And for that reason, because of that back and forth, we have to look out to 100-year projections. Because by 100 years from now, the projections are at such a level that the averages have wiped away, have surpassed all of that up and down, that variability that we see. But that also means that sometimes we get the sense that things are in the distant future, 100 years away, when in reality, a really bad year now could put us at those 100-year projections. And certainly when you're looking at 20, 50 years out, really bad years there are very likely to get us to some of those 100-year projections earlier. And again, some years, it's not going to be as bad. The trends will be reversed entirely. Now, going back to the Burns chapter, Pacific Island Developing Countries, in that chapter they mentioned the Marshall Islands drought in '97. That was an El Nino related drought. There's a story in the Pacific Islands region when the El Nino started. The head meteorologist, Chip Gard, great guy, he was working with FEMA to try to get water to the Marshall Islands in preparation for this devastating drought that was going to happen because of this bad El Nino. Now, FEMA is a disaster response organization. They respond after a disaster has occurred. They are not a preparedness organization. And so what they said to him was, you know, we will respond later to a disaster if it occurs, we will respond accordingly, etc. And Chip said, you don't understand how bad this is going to be. If you don't send water now, you need to send body bags. And was able to affect a lot of change and a lot of implementation and preparedness for this drought. And actually, while the drought was severe enough that water would be cut off for days or even weeks at a time, there were very few casualties, and the Marshall Islands did well enough through it. But again, that's where you can see some years are going to be very bad because of this climate variability. We can see that the trend is going to be toward more drought. Some droughts are going to be devastating. Also in Tuvalu earlier this year, Cyclone Pam left 45% of the population homeless. We say when we're talking about the sea level rise projections with Tuvalu, with Kiribati and the Seychelles, that 50 to 100 years from now, the countries will be uninhabitable because of sea level inundation. But here we have one really bad storm that brought huge storm surge and wiped away housing and flooded 45% of the islands. A bad storm can mean it becomes uninhabitable much sooner, even very soon. So this 50 to 100 year projection is only the best we know with the climate variability, and even with weather events, things could happen much worse and much sooner. So let's tie all of this together. Climate change is a long-term shift. It's happening now, though not everywhere is feeling the same impacts at the same time. With climate change projections, I'm having you look at near-term and long-term predictions, but we have to understand the uncertainty within those predictions. Very likely doesn't mean it's not going to happen, but it could mean it happens 10 years later than where the projection is. And a lot of this uncertainty does depend on what are people going to do about it. And so that leaves me with the question, what are you going to do about it? Here we are, right? For your class activities now and for the rest of the semester, we have a general work on your interviews, your web resources, the workshops. I do have my research proposal into the IRB right now for ethical review. So the workshops will be forthcoming if you are interested in doing that. Keep in touch with me about how your other projects are going if you have any questions, want to talk through any of these issues. And as always, please let me know if you have any questions.